Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a truncated cylinder which has been sectioned by two cutting planes over here. Now we have been provided with a cylinder which is having diameter is equal to 40 millimeter, and this cylinder is resting on its base in the upright position, and the height of the cylinder happens to be 60 millimeter. Now from the left hand side bottom face of the cylinder, a radial cutting plane which is having radius is equal to 24 millimeter. So this is going to section the cylinder as shown in the figure over here. Similarly, there is another cutting plane which is lying at the left top portion of the cylinder. So we have been provided with the orientation of this auxiliary inclined plane or the second cutting plane over here as shown in this figure over here. So this way we have been provided with two cutting planes which are going to intersect with this right cylinder over here. Now let us proceed with the construction of the orthographic projections of the cylinder. So we know that the diameter of the cylinder happens to be 40 millimeter. So as the observer is going to look at the cylinder from the top, so we are going to obtain the circular projections of the cylinder onto the horizontal plane, and the circular projection will be drawn below the XY reference line. Now we can divide the circle into 12 equal parts such that the included sector angle for each of these 12 sectors happens to be 30 degree over here. Now we have been able to mark the 12 points corresponding to the top face of the cylinder outside the circular projection, and the 12 points corresponding to the base of the cylinder we have been able to mark on the inner side of the circular projection in the top view projection over here. And the access points O and O1 corresponding to the top face and the base of the cylinder we have also marked into the top view projections over here. Now we know that the height of the cylinder happens to be 60 millimeter. So now from all the 12 points of the base and the top face of the cylinder, now we are going to draw vertical projectors into the elevation projection view, and we will be obtaining 12 points corresponding to the top face of the cylinder represented over here, and then the 12 points corresponding to the base of the cylinder, they have been marked onto the XY reference line. And now we can see that there is one circular arc which is going to originate from the leftmost point of the base over here, and this circular cutting plane is going to have the radius of 24 millimeter over here. So now we can check this is how this circular arc or the cutting plane, it has intersected with different vertical generators and the base of this upright cylinder over here. So now we can check that there are 9 points which are available corresponding to the intersection of the circular cutting plane with the different vertical generators and the base points of this particular right cylinder over here. Similarly, corresponding to this auxiliary inclined plane which is inclined in such a way that this dimension happens to be 13 millimeter from the right side of the top face of the cylinder over here. Similarly, this point can be located while we mark the distance of 15 millimeter from the top face of the cylinder on the left side projection over here. So now we have been able to mark the orientation of this inclined plane over here. So now we can check this auxiliary inclined plane, it has intersected with different vertical generators and the 2 points corresponding to the top face of this particular right cylinder over here. So total of 9 points of intersection have been obtained corresponding to the intersection of this auxiliary inclined plane with respect to the right cylinder over here. Similarly, this circular cutting plane, it has also intersected with 7 vertical generators and 2 points of the base over here. So these are the 9 points which have been observed by virtue of intersection of the circular cutting plane with the right cylinder over here. So let us obtain the development of the surface of this truncated cylinder with respect to cutting plane number 1, that is the auxiliary inclined plane over here. Now we are going to use the parallel line development method in order to obtain the lateral surface of this particular upright cylinder over here. So now we can see we have drawn 2 horizontal projectors from the top face and the base of this cylinder over here. So between these 2 horizontal projector lines, now 12 segments we are going to obtain over here. So we are going to start development from the vertical edge 1, 1, 1. And then we need to measure the distance between the points 1 and 2, 2 and 3, 3 and 4, so on till we are able to complete the circumference of the cylinder up to the points 12 and then get back to point number 1 over here. So we can see 12 segments we have obtained over here, in which this segment length, this should be equal to the distance between the points 1 and 2 over here. And then the same distance we are going to obtain for each one of these 12 segments which are available with us onto the circumference of this cylinder over here. So now we can mark these points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. Similarly, the 12 points of the base also we have marked onto the development of the lateral surface of this untruncated cylinder. So now we have been able to obtain the development of a cylinder which has not been cut by any of the cutting planes. Now we know that this cylinder has been cut by 2 cutting planes over here. So the first auxiliary inclined plane, it is lying at the top portion of this particular right cylinder, available onto the left hand side of this cylinder over here. Now we can see that if we draw the vertical projector from the points H1 dash and H2 dash, now these 2 points of intersections also we have been able to obtain. So this point we have marked as point A. So point A means now onto the circumference of this particular cylinder, that is into the development view also, now we are going to measure distance between 4 and A, and accordingly one projector line we are going to mark using black color. We can see this projector has been marked with the help of black color line. That is, we want to distinguish between this projector and all the other projectors, because these are the 12 vertical generators which were available with us corresponding to the 12 segments or the sectors of the cylinder over here. Whereas this particular projector has been drawn with the help of black color, because this will facilitate us to locate the position or the distance of the point A from the point 4 into the circumference onto this particular location or the vertical projector. The points H1 and H2, they need to be located. So H1 can be located once we draw the distance between points 4 and A onto the development surface view over here. So we have marked this projector name as 4A. Similarly, as we are going to move from point 9 to 10 alongside the circumference, now this distance we are going to measure. So this distance we have marked it over here. So we have marked this point as 9A. That is, onto this vertical projector line, point H2 will be lying. Onto this black vertical projector line, point H1 is going to lie over here in the development of the surface view over here. So now we know that the first point of intersection of this AIP happens to lie onto the vertical generator 1 dash and 1 1 dash over here. Points A, 1 and 1 1, they coincided with each other in the top view projections over here. So now once we draw a horizontal projector line through point A dash, let us evaluate the intersection of this horizontal line with vertical projector 1 and 1 1 over here. So one point of intersection will be obtaining over here corresponding to point A. Another point of intersection we are going to obtain over here onto the vertical generator 1 1 over here. So now next 2 points of intersection of the AIP with the vertical generators 2 dash, 2 1 dash and 12 dash, 12 1 dash. So they happen to be B dash and C dash over here. So now we know that point B, it lies on 2 dash, 2 1 dash. Point C happens to lie on the vertical generator 12 dash, 12 1 dash. So now once we draw horizontal projector through the points B dash and C dash into the development of the lateral surface of the cylinder, now we have to observe the point of intersection of this horizontal projector line with the vertical generator 2 2 1 and 12 12 1 over here. So onto the vertical generator, this intersection point will be called B, whereas onto the vertical generator 12 12 1, this point of intersection will be labeled as point C over here, because point B lies on vertical generator 2 2 1 and point C happens to lie on the vertical generator 12 12 1 over here. Now the next 2 points of intersection, they are D dash and E dash corresponding to the vertical generators 3 dash, 3 1 dash and 11 dash, 11 1 dash over here. Point D happens to lie onto the vertical generator 3 3 1. Point E happens to lie onto the vertical generator 11 11 1. So now once we draw horizontal projector through the points D dash and E dash, now the intersection of this horizontal projector drawn through the points D dash and E dash with the vertical generators 3 3 1 and 11 11 1 has to be obtained over here. So this intersection point will be the point D over here, and this intersection point obtained onto 11 11 1. So this will be point E. So we have already checked point D happens to lie on 3 3 1 and point E happens to lie on 11 11 1 over here. Now we have got the next 2 points of intersections as F dash and G dash over here. Point F dash happens to lie on 4 dash and 4 1 dash, while point G dash happens to lie on the vertical generator 10 dash and 10 1 dash. So we have already obtained point F. It happens to coincide with 4 and 4 1 in the top view projections. Point G happens to coincide with the vertical projector points 10 and 10 1 over here. So now from this point of intersection, that is F dash and G dash, once we draw the horizontal projector line, now we need to obtain the intersection of this horizontal projector line with the vertical generators 4 4 1 and 10 10 1 over here. So this intersection point with the vertical generator 4 4 1, this will provide us with the location of the point F over here. The intersection of this horizontal projector with vertical generator 10 10 1 will provide us with the location of the point G over here. So now the last 2 points, so they are available with us as H1 dash and H2 dash over here. Now these 2 points, they are going to lie onto the top surface of this particular cylinder, and we have already discussed point H1 dash. It will be lying between the circumference points 4 dash and 5 dash, whereas point H2 dash will be lying between the circumference points 9 dash and 10 dash over here. So now once we have drawn a projector through H1 dash and H2 dash, now the distance alongside the circumference, it has already been evaluated. That is onto vertical projector 4A. the point H1 will be lying. Onto vertical projector 9A, the point H2 will be lying. So we have already drawn the projectors over here, 4A and 9A. So onto vertical projector 4A at the top surface, because from this point, that is H1 dash and H2 dash, once we draw a horizontal projector line, so this horizontal projector line will be drawn like this. Now the intersection of the horizontal projector line drawn through H1 dash and H2 dash with top portion of this vertical generator 4A, this will provide us with the location of H1. Similarly, the intersection of the vertical generator 9A at the top with this horizontal projector line emerging from H2 dash, it will provide us with the location of the point H2 over here. So all the 9 points, they have been appropriately obtained in the developed surface of this truncated cylinder over here. So we can join all of these points, and now we can see this portion of the cylinder has not been cut by this AIP. That is 5 dash, 9 dash, 6 dash, 8 dash and 7 dash. We can see 5, 6, 7, 8, 9. So these vertical generators, they have not been cut by this AIP. So we get a flat portion corresponding to the top face of the uncut cylinder over here, appearing into the lateral surface development of the top portion of this truncated cylinder over here. So now the development corresponding to the AIP number 1 has been obtained. Now let us obtain the development corresponding to the 9 points which are appearing in the front view projections by virtue of intersection of this right cylinder with the circular cutting plane over here. So now we know that the circular cutting plane is going to have the radius 24, whereas the radius of the cylinder is 20. So this arc is going to extend by 4 millimeter ahead of the center of the cylinder. So now corresponding to the 7 vertical generators, 7 points of intersection they have been obtained, corresponding to the 2 points of the base. So the points P1 dash and P2 dash, they have been obtained onto the base of this particular cylinder over here. So now we can check. If we draw a vertical projector line from the points P1 dash and P2 dash into the top view projections, now this point B has been located over here. So B point is located here, B point is located over here again, corresponding to this black projector, which represents the intersection of the base of the cylinder by this circular cutting plane. So now we are going to obtain the points P1 over here between 4 and 5. We are going to obtain point P2 over here between the circumference points 9 and 10 over here. So now total of 7 vertical generators will be intersected by the circular cutting plane, and the 2 points of intersection, they will be available onto the base of this cylinder over here. So let us obtain the top view projections of these 9 points. So I dash point, it happens to lie onto the vertical generator 1 dash and 1 1 dash. So the top view projection of point I will be obtained. It will be coinciding with points A, 1 and 1 1 over here. Similarly, J dash and K dash, they are the 2 points of intersection of the circular cutting plane with the vertical generators 2 dash, 2 1 dash and 12 dash, 12 1 dash over here. So point J dash lies on the vertical generator 2 dash, 2 1 dash, whereas K dash, it is the point of intersection of the circular cutting plane with the vertical generator 12 dash and 12 1 dash. So in the top view projections, point J will be coinciding with points 2 and 2 1, we can check, and then point K in the top view projection, it will be coinciding with points 12 and 12 1 over here. Similarly, another 2 points of intersections, they are there, L dash and M dash. So now L dash is the point of intersection of the circular cutting plane with the vertical generator 3 dash, 3 1 dash, and M dash, it is the point of intersection of the circular cutting plane with the vertical generator 11 and 11 1 dash. So in the top view projections, point L, it will be coinciding with 3 3 1, and point M, it will be coinciding with 11, 11, 1 over here. Similarly, next 2 points of intersection, they happen to be N dash and O dash obtained over here. So N dash, it is the point of intersection of the circular cutting plane with vertical generator 4 dash, 4 1 dash, and O dash, it is the point of intersection of the circular cutting plane with the vertical generator 10 dash and 10 1 dash over here. So point N in the top view, it will be coinciding with 4 and 4 1. Point O in the top view will be coinciding with vertical generator 10 and 10 1 over here. And last 2 points onto the base, they happen to be P1 dash and P2 dash. So P1 dash point, it happens to lie onto the front face between the circumference points 4 and 5 over here. So this point B we have marked, right? Similarly, the point P2 will be lying between the circumference points 9 and 10. So this point B again we have marked. So now we can measure distance between 4 and B. Similarly, we can measure distance between 9 and B over here. And these two vertical projectors, now you can check, we have drawn over here. These points, they have been marked as 4B and 9B over here. So this point was 9A, this point is 9B. This vertical projector was 9A, this vertical projector happens to be 9B. Similarly, this vertical projector was 4A, this vertical projector is 4B. Now onto the vertical projectors 4B and 9B, we are going to obtain the points P1 and P2 over here. So let us obtain the development of the truncated cylinder corresponding to this circular cutting plane over here. So the first point of intersection we have corresponding to this circular cutting plane, it is point I dash. So I point lies onto the vertical generator 1 dash and 1 1 dash. So once we draw horizontal projector through I dash, so this intersection with 1 and 1 1 and this intersection with 1 and 1 1, it will provide us with the location of the point I into the developed surface of the cylinder over here. Now the next 2 points, they happen to be J dash and K dash. So J point happens to lie onto vertical generator 2 dash 2 1 dash and K point happens to lie onto the vertical generator 12 and 12 1 dash over here. So we can check, J is going to lie onto vertical generator 2 2 1, K is going to lie onto the vertical generator 12 12 1. So now once we draw horizontal projector line from this point of intersection of J dash and K dash. Now let us evaluate the intersection of this horizontal projector line with vertical generators 2 2 1, it will be this point, and 12 12 1 vertical generator over here, it will be this point. So here we are going to obtain the point J, here we are going to obtain the point K over here. So another 2 points of intersection J and K, they have been appropriately located onto the vertical generators 2 2 1 and 12 12 1 over here. Next 2 points of intersections, they happen to be L dash and M dash. L dash point, it lies onto vertical generator 3 dash and 3 1 dash, whereas M dash point, it happens to lie onto the vertical generator 11 and 11 1 dash over here. So in the top view, we also knew L lies onto 3 3 1, M lies onto 11 11 1. So now from L dash and M dash, once we draw a horizontal projector line, so this will be the point of intersection of this horizontal projector line with vertical generator 3 3 1, and this will be the point of intersection of this horizontal projector with the vertical generator 11 11 1. So the 2 points L and M, they have been appropriately located into the developed surface view over here. Now the next 2 points which are corresponding to the vertical generators, they are N dash and O dash over here. N dash point happens to lie onto the vertical generator 4 dash and 4 1 dash. O dash point happens to lie onto the vertical generator 10 dash and 10 1 dash. So we have already seen point N, it has coincided with 4 and 4 1. Point O, it has coincided with vertical generator 10 and 10 1 over here. So now once we have drawn the horizontal projector through these 2 points of intersections, N dash and O dash, now let us evaluate the intersection of this horizontal projector with 4, 4, 1. It is this orange line. So this point will be point N over here. Similarly, let us evaluate the intersection of this horizontal projector line with this vertical generator, that is 10, 10, 1 over here. So this point will be the point O. This point will be our point N over here. And finally, 2 points of the base P1 dash and P2 dash. So we know that P1 dash point, it is going to lie on the front side onto the generator 4B. And distance will be this distance from the point 4 over here. So we can check, this is point 4. It is this distance from the point 4. So this point we have obtained as 4B. Onto this vertical generator, this point P1 will be lying onto the base. So this point will be lying onto the base. So P1 has been located onto the vertical generator 4B. Similarly, between circumference points 9 and 10, this point is the location of point 9B over here. So this distance we have plotted. You can check, this is point 9. So this distance we have plotted over here. So this is vertical generator 9B. So onto vertical generator 9B, at the base, point P2 will be located. Why? Because we have drawn horizontal projector line alongside the base over here. So again, all the 9 points of intersection of the circular cutting plane with the right cylinder, they have been obtained into this developed surface of the truncated solid over here. So again, we can join these two arcs over here, and once again, these generators, they have not been cut by the cutting plane, that is 5, 6, 7, 8 and 9. So this surface will be appearing as a flat surface onto the base over here. And once we join this vertical edge and this vertical edge, so this is the remaining portion of the vertical edge 1 dash and 1, 1 dash, which is left behind. So this portion of the cylinder, it has been removed by the circular cutting plane. This portion of the cylinder has been cut or removed by the auxiliary inclined plane. Now we have obtained the development of the lateral surface of the truncated cylinder, which has been cut by 2 cutting planes. One of the cutting plane happens to be a flat surface or the auxiliary inclined plane over here, whereas the second cutting plane, it is circular in nature, and by virtue of the intersection of this right cylinder by these 2 cutting planes, so this is the development that we are going to obtain with the given orientations of the cutting planes over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we obtain the development of the lateral surface of the truncated cylinder, which has been intersected by multiple cutting planes in the different orientations over there. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.